students. Hope you are keeping well. Today we are doing the last part of the topic on acid, bases and indicators. We have already covered bases and indicators. So today let's discuss acids. Welcome. Now an acid can be defined as a proton donor. Now what this means is that during the reaction between an acid and a base, the acid donates an hydrogen ion to the base. That is why it is called a proton donor. Now this can be explained in the equation given below.
Acid as a protons donor. Now, first of all, we need to know why we say acid is a protons donor. What does it mean by protons donor? Okay, acids are substances that form hydrogen ions when dissolved in water, as I told you just now, right? Okay, anything when dissolved in water, it forms hydrogen ion, then it's acids, right? Okay, and a hydrogen ion is actually a proton. Okay, now what does this mean? So why a hydrogen ion is a proton? Okay, now let's see what is hydrogen ion. Hydrogen ion consists of one protons and one electrons. Okay, hydrogen ions are one protons and one electron. There's no neutron. Hydrogen atom has no neutrons. Okay, just one protons, one electron. This is hydrogen atom. Okay, hydrogen atom. So hydrogen atom, there's a nucleus, and inside the nucleus there's one proton, just one proton only, and then there is electrons, one electron. So this is a hydrogen atom. Hydrogen atom. This hydrogen atom, it throws away the electrons. Okay, this is hydrogen H. So when this hydrogen atom, it throws away the electrons, so then there is no more electron, just proton only. Hydrogen atom, it has protons and electrons, but if the hydrogen atom throw away this electron, then there's just protons only, and then the charge become positive, and this is still hydrogen, hydrogens. So this is hydrogen ion, and from here we can see that after hydrogen atom throw away the electrons, okay, then the hydrogen ion is just a proton, right? Okay, so this is a hydrogen ion. So a hydrogen ion is actually a proton. And then acids is a substance or chemicals that give protons to other substance in the chemical reactions. Okay, it gives protons, it gives hydrogens to other substance. Okay, and hydrogen ion is a proton, right? Okay, so therefore acids are called the protons donor. It donates protons. It's a chemicals that donates protons. Now, for examples, let's see these chemical equations. Okay, now this is the arrow, and then there's water here. This shows that these acids dissolve in water. Now, when acids dissolve in water, it will ionize and form hydrogen ion and chloride ion. And these hydrogen ions is the proton. Okay, proton. So that's why we call it protons donor. It donates protons. Okay, the second one, nitric acid. When dissolved in water, it will form hydrogens and nitrate ion. Okay, this is nitrate ion. And the last one, sulfuric acid. When dissolved in water, it will form two hydrogen ions and sulfate ions. Okay, so this is sulfate ions. Okay, so from here we can see that the acids, when dissolved in water, it will release hydrogen ion, and these hydrogen ions are called the protons. They are the protons. So acid is called a protons donor.
Now, an acid can also be defined as a substance that dissolves in water to form hydrogen ions as the only positively charged ions. However, in Form 1 level, you can just define an acid as a substance that reacts with a base to form a salt and water. And that will be a very correct definition of an acid, but at the Form 1 level. But as you move higher, now you can use the other definitions we have talked about to define an acid. These are: it is a substance that dissolves in water to form hydrogen ions as the only positive ions, or you can say an acid is a proton donor. Now we have the term acidity also, which we shall come across in this subtopic. Acidity is the measure of hydrogen ions in a solution. Hence, hydrogen ions are the ones that are responsible for the acidic properties of a solution. Now, if the hydrogen ions are many, it means that particular solution is hyperacidic or has a high acidity. While if the hydrogen ions are few, then it means that particular solution has a low acidity. So acidity is actually the measure of the number of hydrogen ions in a substance. Now, let us look at the properties of acids. This means how acids behave. How do they look like? Now, we have two types of properties. We have the physical properties of acids and the chemical properties of acids. Now, if we begin with the physical properties, then we say acids have a characteristic sour taste. Now, this one can be tested using lemon juice, orange juice. How does it taste? That is what we are talking about, and we are calling the sour taste. I believe every one of you here has ever tasted an orange juice or a lemon juice. Now, another physical characteristic of acids is that they are colorless liquids. You can confirm that. And also, mineral acids are odorless. They have no smell at all. And remember, the mineral acids are sulfuric 6 acid, hydrochloric acid, and nitric 5 acid. But we have other acids which are called organic acids, and those ones have some smell. They have a characteristic smell. So some other characteristics of acids are that acids have pH less than 7. All acids, their pH is less than 7, because we said that when we were learning about the pH scale from 0 to 6, that is where acids lie. That is where acids lie, between 0 pH to around 6 pH of 6. So acids, all of them have a pH which is less than 7. Now, all acids turn blue litmus paper red, and that is normally the test for acids. Some acids dissolve in water to form acidic solutions. No, solid acids. Sometimes we have acids which are supplied in the solid state, like maleic acids, which you will come across them when you get to 4th form. And ethanoidioic also, sometimes it can be in the solid state. So whenever they are dissolved in water, they form acidic solutions. And finally, acids have a scorching effect. If they drop on your skin, you would feel a burning effect. So that is what scorching is all about. Now, there are two categories of acids. We have the organic acids and we have the mineral acids. Now, the mineral acids, as I had mentioned earlier, include the ones which we normally use in the laboratory. The ones we use in the laboratory. Mostly sulfuric 6 acid, hydrochloric acid, and nitric 5 acid. Those are mineral acids. So like I've just said, mineral acids are commercially manufactured and they are commonly found in the laboratory. So those ones we can find them in the laboratory. Then also organic acids are found in the laboratory, some of them, but we can have some which can be found in some types of foods we consume. For example, now let us look at some examples of organic acids and where they can be found. For example, we have citric acid, which is found in lemons, oranges, and other citrus fruits. We have butanoic acid, which is found in beef. We have hexandioic acid, which is found in palm oil and olive oil. We have ethanoidioic acid. This one is found in vinegar. I believe you have vinegar. You have seen vinegar used for cooking, preparing salads, at home. Then we have methanoic acid, which is found in stinging nettle. You know that plant called stinging nettle. whereby if it touches your skin, it really hurts, it really pains and itches. So that one contains methanoic acid, together with the stings from bees and ants. All those stings contain methanoic acid, and it's the one which makes one feel so itchy and pain when they're in contact with such methanoic acid from the bee stings, ant stings, and even the stinging nettle. Now let's move on to the chemical properties of acids. And the first one we are going to look at is reaction of acids with metals. Now, acids react with metals to form a salt and hydrogen gas. Now, the reaction is normally accompanied by effervescence due to production of hydrogen gas. Now, effervescence means the bubbling of a solution. So you will note that there are bubbles forming until the reaction is complete. So that gas which is produced whenever an acid is reacted with a metal is hydrogen gas. And the name of the salt is normally derived from the acid used. Now, for example, if you use sulfuric 6 acid to form a salt, maybe react it with a metal to form a salt, that salt will be a sulfate. Nitric 5 acid will give us a nitrate. Hydrochloric acid will give us chloride. We have ethanoic acid which will give us an ethanoate. And we have citric acid which will give us citrate. So we also have carbonic acid which will give us a carbonate. So the name of the salt will be derived from the acid which is used to make it. Now, let's look at some examples of the equations which we can be able to write on reacting some metals with acids. For example, when you react magnesium with hydrochloric acid, then you form a salt by the name magnesium chloride. Now, the magnesium comes from the metal, while chloride comes from the acid. Therefore, our salt will be magnesium chloride plus hydrogen. Another example is when you react calcium and nitric 5 acid. The products will be calcium nitrate plus hydrogen gas. Then finally, aluminium plus hydrochloric acid will give us aluminium chloride and hydrogen gas. So those are some equations, word equations from reactions involving metals and some acids. Now, something to be noted whenever we are performing experiments with between metals and acids. We need to note that very reactive metals such as potassium and sodium, they react violently with acids and should never be tried in a school environment. So any experiment involving an acid and a metal is forbidden from being performed in a school. Reason is that it is very violent and it can lead to accidents and injuries also. So such experiments should never be tried in a school environment. Now, something else to note is that the reaction between calcium and lead metal. When you are reacting calcium metal and lead metal with dilute sulfuric 6 acid, that reaction will not go to completion. It will just start and stop immediately, slows down and it stops. This is because these metals react with sulfuric 6 acid to form an insoluble coating. In the case of calcium, it will form an insoluble coating around the metal of calcium sulfate. And in the case of lead, it will form lead 2 sulfate. Now, those two compounds formed, they are normally insoluble and they will coat the surface of the metal, and that the reaction will stop immediately. It coats the surface of the metal and the reaction stops. So remember, it is calcium lead metals should never be reacted with sulfuric 6 acid for that reason. Because when the coating forms, the reaction stops immediately. It cannot continue to completion. Now, another example of a metal which will not complete the reaction with an acid is the reaction between lead metal and hydrochloric acid. Those ones again, the moment they react, there will be formation of lead 2 chloride. Lead 2 chloride is also insoluble, so it will coat the metal, coat the surface of the metal. The reaction slows down until it eventually stops, and therefore such reactions should never be tried, or they will not proceed to completion. So another thing to note is that copper metal does not react with dilute acids, and the reason is because copper is lower in the reactivity series, below hydrogen. Hence, it cannot displace hydrogen from an acid. Therefore, whenever you try a reaction between copper and dilute acids, nothing will happen. Copper cannot displace hydrogen in solution. Therefore, the reaction does not proceed. Now, let's see the second chemical reaction of acids, and it is reaction with bases. Now, the reaction of acids with bases is normally called a neutralization reaction. The reason is because acids are neutralized by bases. Bases neutralize acids. So the moment the two react, then there is neutralization. That means that the products formed are neutral products. And we know the products are a salt and water. Water is the oxide of hydrogen, and we said it is neutral. Then the other one is a salt. Salts, most salts, normal salts are normally neutral. Now we'll talk about normal salts in book 2. Now, an example of a reaction between an acid and a base is the reaction between sodium hydroxide and hydrochloric acid. So this one forms sodium chloride and water. So the products are a salt and water. So we get the name of the salt from the metallic part of the base and the non-metallic part of the acid. The two combine to form the name of the salt, that is sodium chloride, then plus water. Another example, the reaction between sodium oxide and nitric 5 acid will give us sodium nitrate plus water. So sodium oxide is the base, nitric 5 acid is the acid. They react to form a salt by the name sodium nitrate excuse me, and the other product is water. Now, let's move on to the third chemical reaction, which is the reaction of acids with carbonates and hydrogen carbonates. Now, acids react with carbonates and hydrogen carbonates to form a salt, carbon 4 oxide gas, and water. A salt, carbon 4 oxide gas, and water. I hope you remember, when it is a metal and an acid, two products, salt and hydrogen. Metal and a base, an acid and a base, then we get a salt and water. Now we are in an acid and carbonate or an hydrogen carbonate to give us a salt, water, and carbon 4 oxide gas. Now let us note the following, that strong acids completely ionize in solution, and examples of strong acids are sulfuric 6 acid, hydrochloric acid, and nitric 5 acids. Those ones are strong acids. When you dilute them with water, then they ionize completely, forming the constituent ions. For example, sulfuric 6 acid will give hydrogen ions and sulfate ions, and the others will behave in the same manner. Now, weak acids ionize partially in solution to produce very few hydrogen ions. So weak acids, they do not ionize completely in solution, and therefore they leave some part of it compact, not ionized. Some part remain as a molecule still combined together, while a few hydrogen ions are produced. And examples of these weak acids are ethanoic acid, citric acid, methanoic acid, and the others which we mentioned earlier. Now, we have some substances which we handle in our daily lives which are weakly acidic substances. Examples are those lemon juices and orange juices. Those ones are weakly acidic. We have sour milk. We have soda. We have stinging nettle. And most insect stings. And also tap water and rainwater are weakly acidic substances. Now someone would ask, why do we say tap water is weakly acidic? Now the question is, where do we get tap water from? Now it can be from rainwater, it can be from the borehole. So what happens with rainwater is that normally in the atmosphere it combines with some carbon dioxide gas, forming a weak carbonic acid. So the moment rainwater reaches down, it is already weakly acidic. So that is why we are saying tap water and rainwater are acidic, slightly, not strongly acidic, but weakly acidic solutions. So something else to note is that strong acids are more reactive than weak acids. Therefore, the mineral acids we talked about, sulfuric 6 acid, nitric 5 acid, and hydrochloric acids are strong acids, and they are more reactive than the weak acids like the citrus acid, the carbonic acids. Those ones are weak and less reactive. And I know you know the reason why. Because these strong acids produce many hydrogen ions, while the weak acids produce fewer hydrogen ions. And in reactions, it is the hydrogen ions which are being displaced. So if they are more, then the more reactive the acid is. If they are few, then the acid is less reactive. So strong acids are more reactive than weak acids. Then also distilled water and normal salt like sodium hydroxide, sodium sulfate are neutral. So those salts, we call them normal salts. Normal salts are neutral. They do not have any hydrogen ion in their formula. And that's why we say they are not acidic. They are neither basic because they do not have the hydroxyl ion. They are neutral. It's also important to note that sodium carbonate and sodium hydrogen carbonate, together with potassium carbonate and potassium hydrogen carbonate, are alkaline in nature. That is something to note. Now, sodium hydrogen sulfate and potassium hydrogen sulfate are acidic. Sodium hydrogen sulfate and potassium hydrogen sulfate are acidic. Now, the moment you see hydrogen included in the formula of a salt, just know that that salt is an acidic salt, because hydrogen ions are the ones that are responsible for acidic properties of substances. Now, from there we can move on to the uses of acids. So, different acids have different uses. For example, sulfuric 6 acid is used as an electrolyte in car batteries. So, those car batteries which normally have acid in them, they are called lead acid accumulators. They usually contain sulfuric 6 acid. And even when they get like, what do we call it? When they lose charge, you recharge by adding dilute sulfuric 6 acid. So sulfuric 6 acid is very useful in car batteries. Now, dilute sulfuric 6 acid again and dilute hydrochloric acid are used to clean metal surfaces. Now, we clean metal surfaces to remove the oxides on them. Oxides coating on them. So sulfuric 6 acid and hydrochloric acids will be very useful in such situations. Weak acids are used to treat insect stings. So some weak acids can be used when someone is stung by something to treat. Then nitric 5 acid is used in making fertilizers and explosives. That is common. Then we have concentrated sulfuric 6 acid is used as a drying agent for gases that do not react with it. For example, concentrated sulfuric 6 acid is used to dry oxygen gas. It's also used to dry hydrogen gas, and so on and so forth. So it's a drying agent for gases. Then finally, you can look at some diagrams there showing the uses of acids, and then that marks the end of our lesson. So can you attempt as many questions as possible about acids so that you are able to ensure you've understood all the concepts that are required to be learned from acids at this level. Thank you, and see you in the next lesson.